Imagine a city with no architects, no blueprints, no central government. Yet, it has ventilation systems, food storage chambers, waste management zones, nurseries, highways, climate control, and emergency response systems. Now, imagine this city is built underground by creatures with brains smaller than a grain of sand. Ants build cities so complex that engineers, architects, and computer scientists study them to solve human problems. And the most disturbing part is this: no single ant understands the city it's building. So how does something so intelligent emerge from something so small? At first glance, ants seem simple. Small insects following invisible trails, carrying crumbs, disappearing into cracks in the ground. For centuries, humans dismissed them as instinct-driven machines, biological robots repeating the same actions over and over. But that assumption collapses the moment scientists began excavating ant nests. What they found were multi-level underground megastructures, some stretching several meters deep, containing thousands of interconnected chambers. These nests aren't random, they're organized, specialized. There are rooms exclusively for raising larvae, others for storing food, separate chambers for waste disposal, and in some species, even fungus farms, carefully cultivated and protected. Ant colonies can contain tens of thousands to millions of individuals, yet they function as a single coordinated system, what biologists call a superorganism. This raises a serious biological problem. Ants have no leader, no foreman, no master planner. So how does architectural complexity emerge without intelligence at the top?
Cities without blueprints. The first revelation is that ant cities are not designed, they emerge. Ants follow simple local rules. If you detect a certain chemical, dig here. If humidity drops, dig deeper. If carbon dioxide increases, open a tunnel. This process is called stigmergy, coordination through environmental feedback. Each ant reacts only to its immediate surroundings, yet collectively, these reactions create large-scale structure. But here's the real strangeness. Different ant species build fundamentally different city designs despite using the same basic rules. Leafcutter ants create vast agricultural complexes. Harvester ants build vertical shafts optimized for airflow. Fire ants construct flood-resistant living rafts. No ant understands engineering, yet their nests obey the laws of physics better than many human buildings. Climate control underground. One of the most astonishing features of ant cities is passive climate regulation. Many ant nests maintain stable temperature and humidity even when surface conditions fluctuate wildly. This is achieved through vertical tunnel networks.
Chamber spacing controls airflow. Heat exchange between soil layers. Leafcutter ant nests can regulate oxygen and carbon dioxide levels automatically, preventing suffocation inside massive underground colonies. Engineers studying these nests have directly applied the same principles to energy-efficient human buildings, including skyscrapers and data centers. But ants didn't evolve this to save energy. They evolved it to solve a far deadlier problem: survival of their young. Number 3. Division of labor at a biological level. Ant cities work because ants themselves are biologically specialized. In many species, workers are not interchangeable. They are physically different. Some ants are born to dig, others to defend, others to forage. In leafcutter ants, soldiers have heads so large they can block tunnels like living doors. This specialization is controlled not by learning, but by developmental biology, influenced by nutrition and chemical signals during growth. But here's the unsettling implication. An individual ant is expendable. The colony isn't. Ants behave in ways that make no sense for individual survival, because natural selection isn't acting on the ant, it's acting on the colony as a unit.
4. Infrastructure that adapts in real time. Ant cities are not static. They change constantly. When food sources shift, tunnel networks reorganize. When threats increase, defensive chambers expand. When floods arrive, entire cities transform. Fire ants can link their bodies together to form floating structures that survive weeks on floodwaters. Underground species can seal chambers, reroute airflow, and evacuate larvae in minutes. But here's the real strangeness. No ant issues commands. The city adapts purely through local decisions, chemical signals amplifying or suppressing behaviors across thousands of individuals. This is the same logic used in modern swarm robotics and AI optimization algorithms. Ants solved decentralized intelligence millions of years before humans even existed.
5. Ant agriculture. Cities that grow food. Leafcutter ants don't eat the leaves they collect. They use them to grow fungus, a species that exists nowhere in nature without ants. These fungus gardens are carefully maintained. Contaminants are removed, temperature is regulated, bacterial antibiotics are applied by the ants themselves. This is agriculture, evolved independently of humans. And it requires a city designed around farming infrastructure, ventilation, storage, waste removal, and disease control. Some ant colonies have been farming continuously for over 50 million years. That's older than human civilization by an unimaginable margin. The most unsettling truth about ant cities is this: intelligence isn't where we thought it was. Complexity doesn't require planning. Order doesn't require leadership. Ant cities prove that intelligence can emerge from simple rules interacting over time. No ant knows the city, yet the city knows how to survive. These underground metropolises challenge how we define intelligence, cooperation, and even individuality itself. Ants don't just build cities, they are the city. And in doing so, they remind us that nature doesn't design with intention, it designs with relentless experimentation, guided by evolution. If you enjoyed this deep dive into one of nature's most unbelievable systems, subscribe for more science documentaries that reveal how the natural world quietly outsmarts us all. If you want to know why the Komodo dragon is more venomous than anyone thought, click the video on the top right. And if you're curious to discover which bird is the ultimate master of deception and manipulation, click the video on the top left. Thanks for watching, and we'll see you on the next one.